In a perfect world, we'd always be able to use the standard normal distribution table. We don't live in that world. In general, once we've found the relevant z-score, we need to recover the value of the variable of interest. IQ is normally distributed with a mean of 100 and standard deviation of 15. So what IQ would place a person in the 99th percentile? If X is a person's IQ, we want to find our X99, where the probability that X is less than this 99th percentile is 0.99. We want to find the Z value, where the area to the left is 0.99. Remember that for the normal distribution, the area to the left of the mean is 0.5, so the Z value we want must be even further over. So we look on the table and find our probability closest to 0.99, and so that will be 2.33. And since we know the mean and standard deviation, we can convert this back into an IQ score. So we know the Z value, 2.33, we know the mean, we know the standard deviation, and we can solve for X. And so X is approximately 135. Or let's say the working lifetime in years of an appliance is normally distributed with mean 10 and variance 4. Calculate the 12th percentile of the working lifetime in years. So we want to find Z12 where our probability that we're less than Z12 is 12%. Since this is less than 0.5, we note that it has to be to the left, and there's a corresponding area to the right, which is complementary to the less than probability. And so what we're actually looking for is a z-score that gives us a probability 0.88. So we look at the table for a probability closest to 0.88, and we find. Now remember, the actual value we want is the reflection of this, so our actual 12th percentile is at negative 1.17. Since the variance is 4, the standard deviation will be the square root. And so translating our z-score back into a lifetime, we have which gives us X equals 7.66, and so the 12th percentile occurs at 7.66 years. For example, suppose monthly demand for a product is normally distributed with a mean of 20 and standard deviation of 2. How much should be stocked so there is only a 2% chance a shop will run out of product? We want to find an amount L where the probability that the demand is greater than L is less than 0.02. Since our region is X greater than L, it will be to the right of some value L. And since 0.02 is less than 0.5, then L has to be to the right of the mean. Otherwise, the region to the right of L will be more than 0.5. And so that means we have a picture that looks something like this, and our right tail probability, this region, will be 0.02. And that means the probability that X is less than or equal to L is the complementary probability, 0.98. Looking at our table, this corresponds to a z-value of 2.05. Now that we have the z-value, we can then find X. So we know our z-value, mean, and standard deviation, and so we find X 24.1 pounds of product. Or let's suppose that in a given year, the manufacturer's product is normally distributed with mean and variance. Let's find an interval centered at the mean containing 25% of the probability. We want a symmetric interval about the mean that corresponds to a probability of 0.25. Now, we can use the table to find the probability that we're less than a certain amount, but how can we find the probability of some interval? Since we want an interval that's symmetric about the mean, the amount above the mean must be half, and the entire area below the mean is 0.5, so the relevant z-score corresponds to a probability of, and from the table we find that that's close to 0.32. And since the interval is symmetric, that also runs to negative 0.32. And then we can recover our profit values. So our z-score of positive 0.32 gives us and our z-score of negative 0.32 gives us. We can also work with percentiles. Suppose a student scored 93rd percentile when the mean was 503 and a variance 9604. Then the same score in another year with a different mean and standard deviation. Assuming that the scores are reported in multiples of 10, let's find the percentile for the second score. So for the first student, the 93rd percentile corresponds to a z-score of 1.48. And now that we know the z-score, the variance, remember the standard deviation is the square root of the variance, we can substitute these in to find our actual score. And since the score is reported to a multiple of 10, this gives us a score of 650. Now, this is the actual score, and on the second test, this score would correspond to a z-value of, and so we can find the probability that we're less than this amount. And so the same score would be in the 90th percentile.